So hello everyone. It's so good for me to be here and to see you all today. I'm very excited to be talking about why effect is more important than ZIO. Why should you care? Well, I wrote ZIO. I'm the father of ZIO. And right now I see a lot of energy in the effect community. And I'm very excited about what Michael Arnaldi and all the other effect contributors are doing, and actually see great things ahead for the future of effect. And in this talk, I'm going to tell you more about why that's the case. So I'm going to talk a bit about ZIO's history, and in particular, how some of the design decisions in ZIO ended up shaping effect. And then I'm going to talk about effect from the early days, the very first commit, actually. We're going to rewind and take a look at Michael's first commit and show that for everyone. You hear, Michael? Yeah. Okay, there he is, yes. Don't escape. We're going to making fun of that first commit there. No, not really. Just joking. And then I'm going to give you the reasons why I think effect is here to stay and could be really, really big. And then finally, I'm going to distill some of my experience over the course of probably, 15 years of open source development in competing in a space and winning for the benefit of all. So I'll talk about my 8 tips to win with effect. You ready? Yeah. All right. The legend of ZIO. Why did I choose that? Well, I like Zorro. I don't know if anyone has seen that movie or read the book, but cheesy pulp. Yeah, a few people out here. Yes, of course, American, yeah, great. And then when putting together this section on sort of the influence that helped shape effect into what it is today, I thought, well, I'm actually going to have to tell people what ZIO is, right? It's not an audience of Scala developers, so I actually need to tell people what ZIO is. And I went through iteration after iteration after iteration, and then finally it hit me how I could explain to this audience what ZIO is. ZIO is effect for Scala, right? And I think that's so ironic, since in the early days, Michael was pitching effect as ZIO for TypeScript. Circle of life. So one of the things I think ZIO really pioneered in its day was pragmatic marketing. There were no talking about profunctors and arrows and monads and so forth on the ZIO homepage. We really focused on bringing home the value proposition to developers. And that's inspired by my vision for FP, is that functional programming is actually an incredibly useful tool for building type-safe compositional systems that we can reason about. And my firm belief that functional programming can positively change the way people build software. And you saw that reflected in the early days of ZIO marketing. And not only did we tweak marketing quite a lot, I think, from the status quo of those days, but we went in and we hacked apart all the traditional names that people used, functional programmers used to describe operations. We turned things like app. Does anyone know why app is named app? Has anyone ever heard of app before? A couple people, a few people? Right, so we hacked apart that and we renamed it zip. We took traverse and turned it into for each. We took point or pure, which is an obscure mathematician's way of naming something, and we turned that operation into succeed, which you know from effect, right? And we got lots of criticism for this. So much endless criticism, but in the end, it turned out to be the right decision. Why? Because people don't care about the math. People don't care about a few people do. I'm a mathematician. I kind of care about the math. But honestly, people care about using tools to solve the problems that they have. And so using an imprecise term that communicates the rough idea is better than using a precise term that scares people away. We also, I think, made a fairly controversial decision to unify async monad with synchronous monad. So basically one data type that unifies both asynchronous and synchronous programming. And that means you look at code and you actually can't tell, is this sync? Is this async? It shouldn't matter, right? Hide that detail. That's a benefit of an effect system, is that it hides a detail that you don't really need to know on a day-to-day basis. We also equipped ZIO with a rich set of operators allowing you to do high-level concurrency operations, like doing a bunch of things in parallel or timing something out, something like that. But then at the same time, we also went deep and gave you software transactional memory to solve all the other problems that you couldn't solve with our high-level primitive operators. We also we pioneered a new way of thinking about resources that doesn't require a separate type. Up until this point in time, you had to use two data types, one for resource types and one for non-resource types, and we figured out how to do it in one type. And that was a real breakthrough. It hadn't been done in Haskell or any other programming languages. We sort of pioneered that in ZIO land. And then even though you don't see the math in ZIO, it really is there, and it's also in effect. There is deep algebraic structure to a lot of the operations in these effect types. And what does that mean as a practical benefit to you as a programmer? It means less edge cases, less surprises. You do fork and join, for example, on an effect, you do something in the background and then later you want that result, and you want that to work in a certain way. And this deep algebraic structure helps ensure that it does work in exactly the way that you think. In addition, we went beyond sort of just the basic toolkit of the time, and we decided, hey, we're going to throw in every single different data type structure you need in order to get stuff done. So we have semaphores and queues and hubs and promises and all these different helper data types, because if you're building a modern application, you need them, and you want them to be nicely integrated into the core. And so we did that at a time when no one else was doing that. We introduced typed errors. There was a time, probably before most of your times, when there was a great debate on the so-called bifunctor error, right? Bifunctor error, scary mathematics. It ended up being, I think, that typed errors won, because they do offer superior reasoning properties. But getting there was a long, hard battle. And then we introduced ZIO environment, typed context for your effects. And we didn't stop there. We integrated logging and config and testing and fiber local references and fiber dumps and async stack traces. All of these things are super boring, right? There's things you need just to get stuff done. But that was the point. We wanted to take FP and we wanted to make it so boring that you could use it at your day job every day to solve problems you were encountering in a way that no one had ever solved them before, in a way that was reasonable, in a way that was principled, in a way that your future self would thank you for solving them that way. And then now, even though the core of ZIO has sort of slowed down and stabilized, and we're very carefully thinking about any sort of change we would want to make in the core of ZIO, the ecosystem continues to, I think, really shine as an example of how to think outside the box and bring the power of functional programming to GraphQL, to interacting with databases, NoSQL databases and SQL databases, to all of these different areas. And ZIO HTTP is, I think, proving that in some cases you can build purely functional software that rivals the performance of low-level systems languages like Rust in some scenarios. So very exciting stuff happening there. And this is the legacy, to some extent, of effect. So in this section, I want to talk a little bit about the birth, the evolution, and the innovation of effect. And I'm going to apologize to even having this section in my slide, because I didn't know until last night over dinner that Michael had a whole talk about this. So I'm sorry, this is going to fall far short of Michael's closing keynote. But nonetheless, it's an outsider perspective, so maybe okay. The first commit, look at that, of effect. Wednesday, November 13th at 12:49. You were on lunch break, weren't you, Michael? 12:49, 2019. Initial with example. That's better than most of my commit messages. Initial with example. and that first commit, this is how effect was defined. It's a function from the environment R, or the context, of the effect to a future instance. And this was actually powered by Fluture at the time, which was later replaced by waveguide, from waveguide, and lots of that was interned, and lots of evolution happened. But all the way back in the early days, there were 3 type parameters to effect, just like ZIO. One for context, one for errors, and one for success. And there were like type classes back in that version and higher kind of types, and they were front and center, and eventually they sort of faded into obscurity as this library evolved. This tweet here is the first interaction between Michael Arnaldi and myself. And when he wrote this message to me on Twitter, I thought, whoa, here's someone who understands very deeply that if you want functional programming to succeed, you can't just take what they do in Haskell and plop it into another programming language, right? Because that's not going to work. You have to take the principles, the ideas in functional programming, and you have to find a way to make that native, to make that idiomatic, to make that serve the audience that you're building for, rather than have them serve the god of mathematics. And that was a unique attitude. I mean, still is to this day. That's actually a fairly unique attitude, and in my opinion is partially why Effect has been and will continue to be such a great success. It's that commitment to pragmatism. We're going to take the good parts of FP and we're going to make them accessible to developers. And so I think this was early in the days of Effect. I mean, just a few months after the first commit, actually. But over the course of 2020, there was a tremendous amount of work being done on Effect. And over time, it started to grow, I think, closer and closer to ZIO, and maybe away from more the FPTS side of things and closer to ZIO. And actually, there was a point later that year, August 5th, when Michael Arnaldi was finding bugs in ZIO through his work in TypeScript and was backporting them to ZIO, which was, thank you so much, Michael, that's good work there. And then I think by around October, well, end of 2020, I think all the basic components of Effect had sort of come to be. This was a full-featured Effect system that had built on a lot of ZIO's learnings and taken that inspiration and made it into something that was very, very powerful and starting to really grab my attention. And the innovation has not stopped. I think you can see at this conference, just with the number of talks here, I mean, just so many talks covering new directions being explored by Effect contributors. And I'm very excited to see the afternoon lineup with, distributed schema problems and Effect CLI and durable workflows with Effect cluster. Some of this stuff is beyond even what's happening in ZIO, right? So this is very exciting work. And the innovation, the attention to detail, TypeScript-specific ergonomics and features that you see in these Effect libraries is stunning, and is a real testament to the strength of the community that Michael has managed to build with the help of many other contributors. So if Effect is a success, it is a hit, as you can see from this conference, the inaugural edition of Effect Days. I hope one of many to come in the future. And I actually believe that Effect is here to stay. So in this section, I want to run through some of the reasons that I believe that Effect is poised to make a bigger impact on commercial functional programming than ZIO. And if you want to think about it at a high level, like in a single picture, it would be this. ZIO took some great ideas in Haskell and made them very accessible and polished and integrated them well into Scala. And Scala is a way bigger market than Haskell. And then TypeScript's taking like ideas and inspiration and all this stuff from ZIO, and it's polishing them, refining them, and it's making it accessible to an audience that is probably 100 or 1,000 times bigger than Scala. That's the high-level way to think about it. I probably don't need to convince you of this, but TypeScript is a hit, right? Look at all the metrics. TypeScript is doing well, and that's a credit to Microsoft. Microsoft has shown an amazing degree of competence, just as a whole, but also with regards to TypeScript. Keeping this language, for example, JavaScript with types, has been essential, I think, for TypeScript slipping into so many organizations around the world. It's just, chart after chart after chart, they all say the same thing. TypeScript is here to stay, and it's going to continue growing. And then also, JavaScript, and therefore by extension TypeScript, has slipped out of the browser now. And now it's on the back end. I remember having a conversation probably 3 or 4 years ago with someone. I said, what language are you choosing to build these microservices in? And they said TypeScript. And I said, what? TypeScript? Back in my day, JavaScript was for jQuery. And then us back-end programmers, we'd be using C, C++, Java, C# Enterprise. No, and I understand the reasons for this, and actually they're quite good and quite compelling. Server-side JavaScript is here to stay. In fact, I talked to a VC about 3 months ago, and one of his investment theses was that in the end, in the zombie apocalypse that we're all looking forward to, dreading, depending on who it is. I'm kind of looking forward to it, actually, myself. In that zombie apocalypse, there's only one language left. It's JavaScript. All the other ones died out. I don't know if I would go quite that far myself, but I do think the importance of JavaScript cannot be overstated. It's going to be around forever. It's the #1 programming language in the world. And it's not going away, ever. And, the same cannot be said, right? You can't say either of these things about Scala. Await async. This is another reason that effect is here to stay. I wrote that if null is a $1 billion mistake, then async is a $10 billion mistake. I said developers got stuck in synchronous is slow when they should have embraced threads should be cheap. I said so they instead invented really awful cheap threads without any understanding of what they were doing. Bad hair day. I got up on the wrong side of the bed. I may have gotten in trouble for that tweet. I honestly don't know. I kind of lost track of the number of tweets I've gotten in trouble for. But I can tell you this, that async exists to give us scalable concurrency. And there's a good way to do that, the best possible way to do that, which is to introduce green threads. And that's what Java has done with Project Loom. That's the beautiful way to solve scalable concurrency problems. And then there's the terrible solution, and that's await async. And JavaScript went down the path on the right-hand side, which you might think is bad, but I'm going to argue it's really good in a second. First, more bad stuff. JavaScript went down this path without any understanding, really, of what they were doing. Promises, the cancellation story around promises, mind-blowing how messed up that situation is, all because there was no deep understanding into the difference between a description, a blueprint, and a thing that's running in motion, which we would call a fiber or a virtual thread or a green thread or something like that. No conception of these distinctions. And not only that, but good luck creating a promise of a promise, right? This Venable stuff in the spec ensures this auto-flattening magical behavior that's going to lead to lots of bugs in any sort of generic code that you write. So this is a huge mess. This is just a steaming pile, really. And so you have, on the one hand, you have the steaming pile, right? That's what everyone gets by default when they open up their browser or Node.js or whatever. And then on the other hand, you have the pristine beauty of effect, which satisfies algebraic laws. It actually has type system, or rigorous type system, to tell you what's going to happen in advance at compile time before you run your app. And which beautifully unifies over synchronous code and asynchronous code and solves resource management, all these other problems, gives you amazing, powerful concurrency that you don't even have to think about. It's just declarative concurrency. It gives you all of the stuff that you could ever possibly want to build a modern, robust, resilient, scalable application. Which one are you going to choose? I can tell you this much about JavaScript. They're never going to go back and change promises or await async, right? That stuff is grandfathered in. So they've made their choice. And the fact that that choice is not great actually means that it's a compelling advantage to adopt effect now and in the indefinite future. JavaScript will never have green threads, but you will always have effect there to take this nastiness and turn it into something that's amazing, that helps you be a productive, powerful programmer. And then the last thing I want to hit on is the concurrency model of JavaScript. Now, I'm not going to claim that JavaScript was particularly well designed. Let's be real. This language was made in 10 days, so I mean, good luck on any of us trying to do better in 10 days, but this is not the world's best programming language, and not a lot of deep thought has gone into it, but by chance, it's like throwing darts. You know, every once in a while you hit the bullseye, even if you don't know what you're doing, like me. And they threw a dart and they hit the bullseye in the concurrency model that JavaScript has. The concurrency model is sequential concurrency with well-defined points when the scheduler will sort of take things over and switch things up. So this is non-preemptive concurrency. And that, combined with shared memory, basically non-preemptive concurrency is the most towards parallelism that you can get, while still having shared memory and retaining your ability to reason about your software. Okay? So most programming languages in the world, they threw their darts, or maybe it was intentional, they ended up with parallelism, true, like hardware level parallelism and or preemptive concurrency, and shared memory. And that combination is catastrophic for reasoning about the correctness of your concurrent software. And obviously languages like Rust try to bring in lots of fancy, heavy-duty machinery in order to help you reason about your concurrent code. But at the end of the day, there's only two reasonable spaces on this dartboard, right? One of them is JavaScript's concurrency model. That's a reasonable space. That's a really good space to be in. And the other one is Erlang, message passing, or sort of what Go encourages. Go does allow shared memory, but Go encourages a more message passing style of concurrency. That also is very reasonable. What everyone else in the world is stuck with, and what they're still baking into new programming languages, that is not reasonable. And you might say, well, I need parallelism. No, you don't. You don't need parallelism. Come on. You really don't. Unless you're doing scientific computing or ML or one of these, you're building TensorFlow, you don't need parallelism. No. You need concurrency. Because, you know, serverless frameworks, every single request is parallelized, right? And then you've got one pod running on this machine, maybe more, it doesn't matter. You've got parallelism at the level of the operating system and the container, and then parallelism at the level of the request. You don't need more parallelism than that. No one writing business applications needs parallelism. What you need is concurrency. You need what JavaScript has. You don't need more, and if you get more, you will pay for that. So for these four reasons, the fact that TypeScript is so popular and getting more popular, the fact that JavaScript could even sort of be the one language that survives to the zombie apocalypse, the fact that JavaScript has that amazing, really amazing concurrency model, the fact that async await is baked into the language and it's not changing, which gives extreme incentive to adopt something like effect to make that reasonable. These are the reasons why I think that effect is primed for growth. I think this conference will be remembered as a tipping point in the history of effect, right? The floodgates are going to open, and as more and more innovation happens in this ecosystem, I expect the size of the effect community and the number of high-quality libraries out there to tremendously amplify. All right, so hopefully it's clear now why I titled this talk, Why Effect is More Important than ZIO. It's because effect stands to make a far bigger impact on commercial functional programming than Scalaz ZIO ever will. Scala is not going to grow. Right? Scala is a niche language that's pretty much settled at this point. TypeScript, on the other hand, that's a mainstream programming language. And your capacity for expanding the reach of effect in TypeScript is unbounded. And then also TypeScript's capacity for expanding the reach of TypeScript is unbounded and very low friction there. So all of the markers are here for significant mainstreaming of concepts and techniques in functional programming. How I wanted to end this presentation is not with a summary, but it's basically distillation of some of the things that I think are important to building a healthy, thriving, growing community that delivers value to businesses. So I'm going to give them to you in rapid succession since I only have 4 minutes and 50 seconds. I won't spend much time on each of these. And I will begin with alignment. It is very critical, especially after seeing some of the stuff that happened with Scala and sort of the direction of the language. It is very, very important for a community to have alignment. And how do you achieve alignment? Well, one of the best ways, I think, is with a value proposition. A value proposition is how you sell this to the outside world. And that forces you to distill the essence of what you're doing in terms of the benefits it provides its potential users, right? So having a clear, crystal value proposition, and you know, I can tell you, like for Golem Cloud, it's basically we want you to, with simple code, build extraordinarily reliable systems, right? The combination of two things there distills the value proposition of Golem. Anything that doesn't help us with that, we cut it. Anything that doesn't get us further in that direction, it's dead on arrival. And same for effect, right? What is that value proposition that gets everyone on the same page and says, this is the direction we're going? Innovation. I think it's so important to, like ZIO did in days past and like Effect is doing now, to stand on the shoulders of giants, so to speak, to learn from the best out there, but don't stop. Question assumptions, question everything, push the frontiers of what's possible.
Why?
Because, it's a good question. It's because you end up discovering new ways to do something that radically solve or radically simplify the way software developers are writing code. An example is, people were telling us in the ZIO organization, it's not possible to deal with the pain of blocking code and non-blocking code. We proved them wrong with industry-first auto-blocking code. They said it's not possible to deal with the pain of environment composition. We proved them wrong with fancy techniques, but nonetheless, they delivered on the promise of radically simplifying that. They said it's not possible to do async stack traces. We said programmers need stack traces even on their async code. We proved them wrong. We kept on proving them wrong, and that's because we didn't listen to all the people who were telling us it was impossible. In life, many times people will tell you something is impossible. Don't believe them. They might be right, but if you believe them before you even try, you will never find out. Number 3, stagnation is very important for any maturing ecosystem. Of course, I say stagnation for shock value, really. What I'm talking about is stability, right? The more mature you become, the more important it is to respect all those who have invested heavily. And that means, you know, some of you will probably go out and create million line of code bases using Effect, right? And you're probably not going to be too happy if there's the next version of Effect that totally requires to rewrite everything. So as you mature, you have a responsibility to... Uh-oh. Well, that's what you get, Michael, for not having your talk come first. I can tell there's... I'll just quickly skip over this point. Pretend it didn't happen. They can cut it from the video. Number 4, I think this is so important. Resist isolationism. Don't live in your own bubble of functional effect programmers, right? Go out and talk to people. In fact, ZIO, some of the breakthroughs in ZIO happened when I went all around the country, all over the world actually, and I started talking to people, and I'm like talking about profunctor optics, and they're like, yeah, John, well, when am I ever going to use this in my business application? Or I'm showing how to stack monad transformers on monad transformers, and they're like, oh my goodness, I would never do this. And hearing that and just talking with like ordinary people who don't know anything about functional programming, it was some of the most useful thing imaginable. You need that circulation of information. Don't lose contact with the outside world. You should be always having conversations with people who don't use Effect, people who hate Effect, right? Talk to people who hate Effect. Why do you hate Effect? Because that will give you more information than you'll get from people who love Effect. Mentorship. So that's flashing at me. So I have like 2 minutes. Okay, all right, I apologize for going over. It's Michael's fault. It's great to contribute, and I know many of you here are contributors to these effect libraries. It's even better to mentor people, right? ZIO has this sort of ethos of every single person has something to contribute. We believe in everyone's ability to build something amazing. And so it's worth, I think, paying it forward and teaching people how to contribute. I've spent probably thousands of hours on Zoom calls with people and stuff, just helping them get stuff over the finish line, right? Mentoring people. And that cultureship of mentorship, it created hundreds of software engineers who are capable of effectively contributing to open source projects. And that culture of mentorship, it helps you as you try to scale and as the ecosystem grows too big for even a small dedicated team of people to maintain on their own. Meritocracy. So I think having a commitment to the best solution always winning, right? No egos, no politics, the best solution always wins. Doesn't matter who submits the pull request. You know, I was called on some bad design decisions I made in ZIO, and I'm so grateful for it. We had a philosophy at one company I worked for where there's no your code and my code, there's just the code, right? There's not your code or my code. There's not your idea or my idea. There's just this idea and that idea. There is no person, right? We want to win, right? You want to win. You want to build the best solution for your users. Then no egos, no politics. The best solution always has to win, without exception. And if you go into it with that sort of mindset, you know, you don't tolerate anything else. Partnership, which is about adopting a positive sum mindset. And you're not competing against other people in TypeScript. You're not competing against other people in JavaScript, right? JavaScript's going to win the whole world. The pie keeps growing. The JavaScript pie is growing. TypeScript pie is growing. Effect is growing. Go into it with an attitude that we're going to make everyone happy, right? We're going to build a big thing, and we're going to make everyone happy. And that's, I think, the way to approach competitive interests. And then finally, number 8, and I'll end the presentation with this one, which is remember why you began this journey, right? And where you're going. Keep that in your mind. That fire, that passion that burns inside you for introducing a better way to write software, keep that alive. Grow that fire, because it's hard to get up every morning in the day and deal with open source entitlement and this and that and all the stuff that happens inside these open source communities, and then do that year in, year out for year after year after year after year. You need to remember why you're there. And that passion, that excitement, that energy, it's contagious. It really is. Like to be in a community of people all excited about effect or, you know, working out or killing zombies or whatever. It's like that is contagious. And that's a good, positive type of peer pressure, I think, that we could all use more of in our lives. Well, I hope you've enjoyed that. I'm very excited for the future of Effect. I think that what Michael Arnaldi is doing here is very, very important. And I've always joked with him, like, you know, if this whole Scalaz ZIO thing doesn't work out, I might find a home in the Effect community. And well, here I am. Thank you so much.